Hello everyone and welcome to this virtual presentation on ExoArm, patient rehabilitation, mobility and heavy lifting using COTS components. I am Mutasib Alam Choudhury and my co-authors of the paper are Kazi Azmain, Faik, Tanzim bin Khalid and Shania Siddiq. We are from North South University, Department of Electrical and Computer Engineering. So now let's move on to the intro part. From the topic, many of you have already guessed that we will talk about exoskeleton. Yes, we will. What is an exoskeleton? Exoskeleton for humans are controllable and wearable device that enhance the human performance. In modern days, there are many sectors which are using this exoskeleton for enhancing the capability of their workers. We can see the use of this exoskeleton in defense sector, in heavy lifting industry, or in medical sector. There's another thing that we used in our topic is that COTS product. That means the commercially off the shelf product. We build our design using these commercially off the shelf materials, which are not very expensive but reliable. Moving to the next part, which is the physical disabilities. We can see that 10% of Bangladesh's population are disabled, and according to Bangladesh Bureau of Statistics, 39% of them are physically disabled, and also 42.96% disabled people are work deprived. So they can't get work because of their disabilities. Now, come to the motivation part. So we like to build a device or we like to create a platform which will aid people with physical disability to lift objects. And also we would like to help the stroke patients for post-stroke arm rehabilitation. For that, there must be some key features in our device, which are affordable, lightweight, wearable, and reliable. First one is the affordable. As we all know that affordability in Bangladesh is a major thing. In case of many people, we can say that they cannot afford a device which is quite expensive. So we would like to lower the price so that any disabled people can buy this device or use this device. Second one is the lightweight. Lightweight is an important thing because it will be a wearable device. So if it is lightweight, then the user will feel comfortable using this device. And fourth one is the reliability. As it will act as a part of our body, so it has to be reliable. Moving to the next slide, which is the previous words. So as we are building device for the rehabilitation purpose and we are building this device for the forearm rehabilitation. We have gone through many research works and found that there are some works which helped us to build this device. The first one is the Arm 3, which is a non-portable arm therapy exoskeleton with ergonomic shoulder actuation using motors. The second one is the retainer. A gravity compensated retainer exoskeleton is designed allowing voluntary arm movement for stroke rehabilitation. And the third one is the exoskeleton. Arm exoskeleton for stroke rehabilitation using glass motors. Here you can see in the left side, the first one is not portable and they used heavy motors and seems quite expensive. Second one is reliable, but it is only for forearm movement. You can't take a heavy weight using this device. And the third one is the same, which they use glass motors, which is quite heavier and not so reliable. Moving to the next part, which is the proposed system. So our proposed system is divided into 4 parts. The first one is the execution sector or the execution unit. In the execution unit, we use linear actuator. And second one is the sensing unit, and we use myo-wire muscle sensor for the sensing unit. And the third one is the processing unit. And we know that there are a lot of PID controllers, and among them, we have choose the Arduino Uno as our processing unit. And fourth one is the structure. Using a lightweight and comfortable structure for this design is very important. So as you can see that the name of our device is ExoArm, and it is given in the upper side. In the left side, you can see a picture of a linear actuator that we use. It is quite good device to use, and it is quite heavier. Not in the weight, but it can pull a lot of weight. So what it does, it executes the command and help the structure for lifting weight. Second one is the MyWire muscle sensor. As you can see in the middle, the MyWire muscle sensor is a sensing unit which senses the electrically activated muscle signals, or we can say the EMG signals, and sends it to the Arduino. And another important thing here is the position of the or you can say the placement of the MyWire muscle sensor. So there are three electrodes that has to be attached. The first two has to be attached in the muscle, and the third one, which is the black wire, has to be attached away from the muscle, which is the reference, which is called the reference. And third one is the lightweight structure. Here you can see the whole structure of our ExoArm, and it gives support to the arm, and it is lightweight and able to take good amount of weight. So here are some more pictures of our design, and the left one you have already seen, the middle and the right one. Here you can see the 3D design of the structure, and in the right one you can see the 3D design of the joint. The design of the joint is one of the most important and unique thing in our project, because it helps to translate the maximum power from input to output, and also it creates a sidewise movement for the user beside the extension and retraction. Okay, now moving to the working methodology. As you can see, there are 4 stages, and we divided our working methodology in 4 stages. So first stage is for the myosensor. Here the myosensor senses the EMG signal when there is a flexation of the muscle, and it collects all the EMG signals and sends it to the Arduino. The second stage is the processing unit, or we can say in the second stage, the Arduino, which is the processing unit of ExoArm, processes the analog signal and converts it to the analog values. And in the third stage, depending on the analog values, the Arduino takes decision, and using digital pins, it sends the signal to the relay board. Here, the third stage, we have to build a program so that the Arduino understands that when it should give forward command to the linear actuator, and when it should give the reverse movement command to the linear actuator. In the fourth stage, here, after receiving the signal from the Arduino, the relay turns on. The relay then turns on the linear actuator. That means on the Arduino Uno, 2 data pins are going to 2 relay boards, and from these 2 relay boards, depending on the command of the Arduino from the Arduino, if the relay 1 is activated, then the linear actuator goes forward and our program extends. When the command comes to the relay board 2, then the relay 2 activates, the relay 2 is activated, and linear actuator goes in the reverse direction. So the next part is the graphical representation. Here we can see the transition from muscle flexing to relaxing. The whole value comes from the myowire muscle sensor. Here you can see when we flex our muscle, the forward movement of linear actuator begins. And the analog value for this is around 627 to 629. And when the muscle relaxes, the linear actuator goes to the reverse direction. Also, there is another part in our design, which is if any user holds or flexes his muscle for more than 10 seconds, then the linear actuator will hold its position there until the user again flexes muscle. So using that thing, the user can hold a certain level up to the time he or she wants. So next part is the mathematical equations. As you can see in the picture, there is the force direction of the whole system. The F1 is the force from the linear actuator, which is 1000 Newton in our case, and the translated force, or you can say the force that we are getting for lifting the weight, is F2y. And A, B, C are the distances here given, and small m denotes the structural weight, which is 2.2 kgs, and capital M denotes the load mass. So here I denote the moment of inertia, and d square theta divided by dt square is the angular acceleration. So coming to the result, we can say that there are some criteria for every design that indicates that a design is a good design or a bad design. So in our case, these 4 points that you are seeing in the screen are those criteria. We have achieved all of the 4 criteria, and here I am describing how we achieved that. The arm rehabilitation. So as I said that we made exoskeleton for forearm called ExoArm, which can replicate the forearm movements. So in that case, for the disabled people who cannot move their hand or who doesn't have the portion of their hand, can use the design, and they can lift any weight using this design. And the stroke patients can rehabilitate using this ExoArm. Second one is the weightlifting capability or weightlifting capacity. The maximum weight or the maximum mass that we lifted using our device is 20 kg. Though the theoretically it was 21.7 kgs, but in the laboratories we tried with 20 kgs of weight and successfully hold that weight for a longer time. Then it comes to the lightweight of the structure. As the user has to use or wear this design in their body, so it has to be lightweight. And as I said earlier, that the weight of our structure is 2.1 kg, and in addition to that, the material that we use to hang the device with our body is so perfect that it easily passes all the weight of the structure equally through our body, and thus the user will feel very comfortable using this design. And in our laboratory, we have wear these suits for hours and tried many things, and all of the tests that we conduct using this device has gone right. The last one is a lower power consumption. We used a 5200 milliampere hour lithium polyion battery for the input of the linear actuator, and using that lithium ion battery we get 4 to 5 hours of battery backup. And in that 4 to 5 hours, most of the time we try to put some weights. And another thing is that if a user uses a pair of rechargeable lithium-ion battery, he or she can use this device for the whole day. And coming to the future world, that we know that no device in this world is perfect. So that's our devices. So the main thing that we need to upgrade in our device is to use an arm bag, which is quite easy to wear, and also it uses Bluetooth technology to transfer the data. That means we can easily use this my armband to our device and make it more comfortable for the users. The second one is the increase of degree of freedom. As you can see that we have a very few degree of freedom, but in the future we are trying to upgrade this device, and we also want to add newer degree of freedoms for shoulders and arms and also hands. Finally, we are at the end of our presentation, and thank you very much for listening me, and please feel free to ask me your queries. Thank you.